Plastic has been the lifeblood of the modern society. It has achieved properties that no other substance can ever retain. It does jobs that satisfy our human everyday needs economically and essentially cannot be replaced by any other material ever known to mankind in existence. Plastics is one of the most versatile and durable and cheapest material to ever be made. But this wondrous miracle that germinated from the depths of chemical engineering also has some drawbacks. Since it's very durable, it does not decompose like any other biological material. It just hangs around for 600 years till it breaks into smaller and smaller pieces of plastic. And we never took the responsibility of disposing it safely. And per annum, 8 million tons of plastic end up in the oceans and now has left over 1 million marine animals dead in its wake. Now it's coming back to us from the bottom of the food chain. How do we stop this cataclysmic environmental disaster? And if we do have a solution, and it must come fast, luckily we do have one. Plastic named PET constitutes 72% of the world's plastic usage and is naturally the number one killer of marine animals. So I have proposed a machine that not only has the ability to break PET plastics down in a safe manner, but also has the ability to extract the monomer compounds that composes of the PET's molecular macrostructure, namely ethylene glycol and terephthalate acid, which has various other roles in many other industries other than being used as a polymer making in the production of PET plastics. So, how do we achieve this process? Well, this can be achieved by utilizing a special enzyme known as PETase that has evolved in a bacterium known as ideonanosgenesis that is known to reside in places rich with PET plastics. So, in principle, I am proposing a technology that not only has the ability to break PET plastics in an eco-friendly manner, but also harvests the useful substance that composes these PET plastics, essentially redefining the term recycling. This cylindrical body here is known as the PMC, or also known as the plastic maturing cabin. This is where the PET plastics is segregated with the enzymes PETase and undergoes a 14-day maturing process where the PET plastics is converted into ethylene glycol and terephthalate acid. So, this component has a PETase enzyme unit which supplies the enzymes and the heater and a high industrial precision thermometer and IR spectrometer to see the chemical signature at the end of the process to make sure whether ethylene glycol or terephthalate acid is there. And lastly, the water composition unit, which measures the pH and etc. to optimize the temperature, the pH, and the enzyme culture to maximize the productivity of the enzymes. After the contents go through a maturing process, they are allowed to slip down the fuselage and settle on the central bottom of where you see this cylindrical tower. So, this is the fractional distillator. This is to purify all the three components that were part of the maturing process: the water that was there to permeate and allow the enzymes to thrive, the ethylene glycol and the terephthalate acid, which was the output after the maturing process. After that, they go into their respective tubes where they are going to be let into storing capacities. While the water is just reused the ethylene glycol is sent off to the storage silos, and while the terephthalate acid settles down here to be molded into ingots. And there you have it, the process of this machine. Ladies and gentlemen, introducing PETcrm.